Special products. So when we're multiplying polynomials, there are some special cases that are worth looking at. And the ones that you'll see in this Algebra 1 course are these three cases. So two of them are just, well, what happens if it's squared? What happens if it's the same thing multiplied by itself? And we've taken this step back to make it more generic, where we're just calling the first thing A and the second thing B. So it might be like x minus 7 quantity squared, or 2x plus 3, take that whole thing and square it. And we're looking at that in that very generic, we're calling the first one A and the second one B sense, so that we can see what happens overall. So let's take a look at this. If I have A plus B squared, well, squaring means the whole thing times itself. A plus B times A plus B. And then I can use either of those methods for multiplying polynomials that I showed in another video. So I might use, for example, the method where I just use the distributive property and I say, well, I take the first thing, times it by the second thing. I don't know what A is, but when I multiply it by itself, I'm going to get A squared. And I have no idea what either A or B are, but when I multiply them together, I'm going to get A times B. And I can just write that as AB, since they're both letters rather than numbers, so it's clear that it's a multiplication operation rather than individual digits. And I can do the same thing for B. B times A sounds an awful lot like A times B, so I'm going to write it like that again, using the symmetric property of multiplication, or I guess the commutative property of multiplication would be the property there. Let's not worry about that today, but yes, it would be the commutative property. And last but not least, B times B would be B squared. So I have my four terms. A squared, I've only got one thing that's an A squared term, so there's nothing to combine that with. But these are identical. So since that's identical, I have two of them. I have one here, I have one here, I have 2ab plus b squared. So this first special product is a kind of general formula or template or rule that if I have something like this that is squared, that's equal to this. So let's maybe look at one that has a few more numbers in it and maybe some x's. I had x plus 3 squared. First, I'm going to multiply that one out the long way, and then I'm going to show you how you can use that as a shortcut. So that'd be x plus 3 times x plus 3. Well, let's see here. X times x is x squared. X times 3 is 3x. Three times x is 3x. And 3 times 3 is 9. I can combine some like terms and get x squared plus 3x plus 3 more x would be 6x plus 9. Or I could use this shortcut directly. I could say, well, my A is x, and my B is 3. So every place I see an A, I'll put x, and every place I see a B, I'll put 3. So if I do that, I'd have a squared plus 2ab plus b squared. Well, my a is x, so I'd put a there and square it, plus 2. Oh, my a is x, so that should be an x, plus 2x. And then my b is 3. So I put a 3 plus my b is 3. So I put a 3. So I've taken this formula and plugged in my x and my 3 in for my a and my b. And so I end up with x squared is x squared. 2 times x times 3. 2 times 3 is 6. So I get 6x plus 3 squared is 9. So I get the same answer both ways. And this is a shortcut special product that you could use to get there from here. So let's go through the other two special products as well. I have a minus b squared, then that would be the same as a minus b times a minus b. And I can multiply that out again. A times a is a squared. A times negative b would be negative ab. Negative b times a would once again be negative ab, since I can continue to use that commutative property of multiplication to move my a and b around instead of writing that as negative ba. It's the same, and I'm just putting them in alphabetical order to make it easier to see my like terms. And negative b times negative b, a negative times a negative is a positive, so I get positive b squared. Combine some like terms, I will get a squared minus 2ab, since I have two ab's here, they're both negative, plus b squared. So my second special product formula or rule or pattern would be that a minus b quantity squared is the same as a squared minus 2ab plus b squared. So we'll look at another example with that. That's more of an algebra example. If I have, this time I'm going to use a little more complicated one. What if I have 3x minus 2? Because I haven't shown you one that has something next to that x and that's someplace else that people can get a little thrown by this. So I want to make sure you've seen some examples like that. So 3x minus 2 times 3x minus 2. I could multiply this out or I could use the pattern. I'll do it both ways. 3x times 3x. 3 times 3 is 9. X times x is x squared. So that's 9x squared. 3x times negative 2. 3 times negative 2 is 6, so I would get negative 6x. Negative 2 times 3 continues to be 6, so I get negative 6x. And negative 2 times negative 2, a negative times a negative is a positive, so I get positive 4. I can combine my like terms, and I get 9x squared minus 12x plus 4. And the other way I could have done that is by using this template. And this time, my a would be 3x. And my b would be 2. So I have ax squared minus 2ab plus b squared. And you'll notice with this b, I didn't grab the sign, because here is my pattern. And so I've already dealt with the sign, all the places the sign needs to be in my pattern, and I'm just grabbing the letters. So I need to put in 3x for my a, negative 2, that'll be AB. I might as well put both parts of that. I'll put the rest of my template in this color. The only reason I'm doing all of this now is so that I can switch colors more quickly. I wouldn't do that if I weren't trying to show you where everything was coming from. So I'm grabbing another A. My A is 3x. Need to grab a B. My B is 2 plus b squared, b still 2. And so now I've plugged everything in and I can do all of my multiplications. 3x squared, 3 squared is 9. X squared is x squared. This is the place that I will see the most mistakes made, is that people will decide this should be 3x squared instead of 9x squared. So review your properties of exponents if you're not entirely sure why this happened. But it's because you need to square that 3 as well as that x, because they're both inside the parentheses, because they're both part of A. Minus 2 times 3x times 2. 2 times 3 is 6, times 2 is 12, so negative 12x. And 2 squared is 4. So I got the same answer both ways. It's good to be aware of these shortcuts, but it's understandable if you're not comfortable yet doing it this way and you choose to do it this way every time. So at this point, it's kind of a choice, but you should be aware of the existence of these shortcuts because they'll become important for some future topics. And we have one more special product that we're going to be learning about today. And that's the one where something kind of cool happens. For, math teacher definitions of cool, which are, different than monster truck definitions of cool, definitely. So, anyway, what if I have a plus b times a minus b? And this has a special name. This is called the difference of squares, and we'll see why in a minute. When I multiply these together, so there's nothing to expand here. I already have 2 of these, so I'll be going straight to the expanding part. A times A is A squared. A times negative B is negative AB. B times A, and you'll notice there's no negative sign here because this was a positive B, that's a positive A. So that's going to be positive AB. And then B times negative B is going to be negative B squared. Because the signs are different, a positive times a negative will be a negative. So here, when I go to combine my like terms, unlike with these guys, where combining those like terms, I got a middle term that was doubled. Here, I'm going to get a squared. These are going to cancel out. They are exactly opposite each other. So just like negative 2 plus 2 is 0, or negative 7 plus 7 is 0, negative AB plus AB is 0. So this just cancels out, and I just get a squared minus b squared. And that's why this is called the difference of squares. squares because I got a square there and a square there, and difference because I'm subtracting. So this one has that special name, and that is something that you may see in other parts of the class, and so I wanted you to be aware of that special name. And let's look at an example with numbers for this one too. Well, and x's. So if I have x plus 7 times x minus 7, I've got the same thing here as I do here, except the signs are different, and that's the only difference between my two things. So when I go to multiply them, I get x times x is x squared. X times negative 7 is negative 7x. 7 times x is 7x. And 7 times negative 7 is negative 49. So when I go to combine like terms, I get x squared. If I have negative 7x and I add 7x to it, I don't have any x's anymore. They've zeroed out. So I get just x squared minus 49, which is 7 squared. So those are the three special product patterns that are really useful with these fancy words here. Linear binomials, things that don't have any squareds in them here, and there's two terms in each of them, so they are binomials. So these are the three special product patterns that are important for you to know right now.